There is an old quote by Alfred North Whitehead that all Western philosophy is only footnotes to the work of Plato. Now, it may be true and it may be false, but one thing for sure, we cannot say the same thing for Western math. We can't say that all Western math is footnotes to Euclides and Archimedes. Why? Because they didn't know or they didn't invent calculus. And this is what we want to talk about. Why calculus is so important and why it is beautiful. And for this, I have a very special guest today. And my guest is Professor Stephen Strogatz. Professor Strogatz is professor of applied mathematics at Cornell University. He is known for his work on nonlinear system and for his research in a variety of areas in applied mathematics, including mathematical biology and complex network theory. He is also the author of several popular science books, including The Joy of X and, most recently, Infinite Powers, about the beauty of calculus and why calculus is the language of nature or the language of God. And he also had a guest appearance in one of 3 Blue 1 Brown episodes about the problem of Brackenstock. I just hope I said it correctly, but I think I didn't. So Stephen, thank you so much for coming. How are you?
Great. Thanks a lot for having me, Roy. This should be fun.
Yes. Now, the beauty of calculus, okay, let's start at the beginning, okay? What can we say? You start your book, you begin your book with a great story, a great peculiar meeting between the late Hermann Wouk, the great American Jewish novelist, with Richard Feynman, the great American Jewish physicist. And during this meeting, Feynman said to Hermann Wouk, you should learn calculus. It is the language of God. And Hermann Wouk was a very religious Jew, so he went on to learn calculus, or at least to try and learn calculus, but he didn't succeed. He didn't succeed. You finish your story by the sad fact that he didn't succeed. So I want to start right at the beginning. Do you think that calculus, or the beauty of calculus, is something that's available to everyone?
I do think so. And I hope so. I realize that it's asking a lot. Many people have had bad experiences in math class in school, even before calculus, right? People sometimes get turned off by algebra, or some people even earlier with fractions in arithmetic. It can be very confusing to think about decimals. But yeah, I mean, in the case of Hermann Wouk, as you say, he described himself as a person in the humanities. He loved philosophy, which I know is one of the topics that you do on this show, and that I look forward to having some philosophical discussions with you. But yeah, so Wouk was well-versed in music and philosophy, literature, and a great writer. For your listeners who may not be familiar with him, he was from my parents' generation, one of the great American writers in the years after World War II. And he wrote a couple of big books about World War II. But he did have this, in preparation for, just if I can fill in a little more of the story, he wanted to, sort of write the definitive novel of that time. And people told him, you should interview the physicists who worked on the Manhattan Project, who built the atomic bomb. And that was why he met Richard Feynman, the physicist. And they found, as they started talking to each other, that they had some things in common. They both grew up in New York City. As you say, they were both from Jewish families. Wouk was very observant. Feynman was an atheist, but they both had a good sense of humor. They enjoyed joking around with each other. And but as Feynman was leaving the meeting, he asked Wouk, do you know calculus? And when Wouk admitted that he didn't, Feynman said, well, you better learn it. It's the language God talks. And so, as you say, there is this question, how would somebody who's not trained in the sciences or in mathematics hope to understand something like calculus? And so Wouk says he tried to learn. He tried going back to, high school classes. He tried reading books on his own. He even hired an Israeli tutor to teach him a little Hebrew and some math.
By the way, Hebrew
But
is the real language.
He found it very difficult. Sorry?
I said that, by the way, Hebrew is the real language of God, but never mind.
That's right.
So he tried to learn two languages simultaneously. This was the problem.
Yes. Maybe so. Yes. Well, anyway, but your question to me was, is it available to anyone? Is the beauty of calculus, and more generally, I guess, the beauty of math, available to anyone? And I want to believe that the answer is yes. But how? I mean, to become good at calculus, like to actually do it, could take years of study. And so I don't think that's what we want. I mean, most people are not up for that kind of effort. Why? I mean, why should they care? Most people live their whole life without knowing math, and everything is fine. I mean, we should accept that as a first fact, that many people don't really understand math, and it's perfectly fine. They have a good life. They can function well in society. They can have a happy family.
But
I mean, it's not like,
even, but with your permission, I think that this is
sure.
This is the first generation that people are proud of their ignorance. You know, in the entire course of history, people didn't know math, people didn't know philosophy, but we had like the sense of what it means to be an educated man. If you look at, you know, the greatest book by Will Durant, the greatest book of Mortimer Adler, you see calculus, you see the Principia by Isaac Newton. But this is the first generation that I can think of that people are proud, are genuinely proud of their ignorance. They say, I don't know math and I'm proud of it. And I think...
Okay, let's discuss that. It's an interesting question. I wonder if they're sincerely proud or if they're embarrassed and it's a defensive posture that they pretend to be proud. I can't believe people are proud of being ignorant. I think
okay. But this is the first time that people say out loud,
they admit it.
Without the psychology behind, I'm proud of being ignorant of math. Now,
they don't act ashamed. I think you're right. They don't. Well, some people do act ashamed. I can tell you, because when people hear I'm a mathematician, and I know you have some training in computer science yourself, you will find people admit, oh, I was never any good at math, or I don't have a head for numbers. But that when people say that, I hear it as a defensive, they're embarrassed. They're a little bit ashamed of themselves. Some people are aggressive about it. Some people, I think, are annoyed that their math courses in school were so bad and that they had trouble seeing the point of it, or, you know. So it's an interesting question, though. I mean, are they, in any case, whether they're proud of it or ashamed of it, I think we can all agree that a large fraction of the population does not understand advanced mathematics, and even high school mathematics.
And it's not just advanced. There is a great book that I read and read and read over and over again, The History of Mathematics by David Burton. And he said at the beginning that the world, you also have it.
There's my copy, David Burton.
Yeah. So, and they also say that the meaning of the word math, it comes from the Latin of the Greek, meaning think good about something. So you should think straight. You should think in a good manner about it. Okay, and this is like the essence of math. And I had like a talk. I heard a talk from Conrad Wolfram, the brother of Stephen Wolfram from the Wolfram Alpha, and he said that math is divided into 4 parts, and the part one is ask the right question and then formulate the question into equation, solve the equation, and then get back the results to the real world and verify. And most people, even professor at math professor at Cornell University, I'm not saying that when we teach calculus, we miss this part because, and you know that many calculus students who take calculus 101 or we take even advanced calculus, if they read your book and you have a great book, they will be, this is what it's all about. Now, why didn't you, like all math professors, told us, why didn't you tell us that this is so beautiful? It's your fault, basically.
Well, thank you. I do think it's beautiful, and it's also very powerful. I think, calculus is one of the all-time great ideas in the history of human civilization. I think it's right up there with ideas of human rights and democracy and evolution, quantum theory. I mean, there are a few ideas that have really, the invention of the computer. I mean, these are things that have changed the world, really, truly changed the world. And calculus is one of them. So I feel like it's a gift to give to people if I could help them understand why this is one of the greatest ideas. Why would I say that? And it's not just like many of your listeners or viewers may have taken calculus in high school or college, and it was a lot of techniques to learn to do derivatives and integrals. But what's the point, right? Why does this matter? And as an applied mathematician, I mean, that's my own field, math applied to the real world, math applied to technology, to science. I see calculus enabling everything, every whether it's radio or television or even computers themselves, or getting to the moon.
Elaborate on this subject, because many people who are not familiar with calculus, because applied math is nothing but differential equations. But many people who are outside this realm say, but how, the world of Disney or Pixar or animated film or radio or television or cell phone is connected to the derivatives and the integral that we're forced to do in high school. So if you could just draw the line, which is very obvious to us, but it is very transparent to anyone outside the realm of math.
Good. Okay. Yeah, we should try to do that. And I really do try to do that in the whole book, because you're right. It's not obvious to people. What is the connection? So you mentioned Pixar. Let's think about something like that. Okay. Computer graphics that let us see Shrek or the characters in Toy Story or Finding Nemo. Obviously, those are not creatures that exist. They're in the computer. Now, how do we make a picture? Let's say, if you can remember Shrek, he's got a big round stomach and his round head. It turns out that round shapes are actually subtle to represent, because if you draw a straight line, that's not round. So to capture something that's round, what people do in computers is make many little patches of triangles or squares or other things made up of straight lines, but they're so tiny that they can put them together in a gigantic mesh. You may have seen pictures of like Shrek represented as a wire frame, like billions of little rectangles or triangles. If they're so small, they can approximate a curved surface like the face of a person or Shrek's round stomach. So the animators at companies, look at that. Thank you.
I can be a great TA.
That's a perfect example, right? I mean, here we see Shrek's face being represented by all these little rectangular patches. And you can represent a smooth surface by shapes that have pointy corners. As you say, with the wire frame. So then, if you want to animate Shrek and make him move around, and his clothing deforms as he runs, all of that involves ideas of calculus, how to make the motion look realistic. I mean, if people are wondering, what is calculus? What's a simple definition? Let's think of it as the study of change, continuous change. It could be continuous change because of motion. Someone's walking around or a rocket going to the moon. It could be change in the level of virus in your bloodstream. If you have, this new COVID virus or HIV or something else. So epidemiologists use calculus. It could be change in the electric field in this room as I try to communicate wirelessly. I mean, we're using it everywhere. And as I say, all of modern technology depends on this language of change at every scale, from atomic to galactic and cosmic. It's amazing. This language of calculus applies at every scale and essentially to every force, every part of physics that we know. Even with the quantum revolution of the 20th century, The language of quantum theory mathematically is still calculus, even though the physics has now overturned Newton's ideas. The math is still the math of Isaac Newton.
Okay, so again, Galileo once said that if we want to, there is a book of God's word and the book of God works, and if you want, and the book of God works is nature, and if you want to read the book of God's works, you need to learn the language, and the language of the book of God's works is the language of math. Now, Galileo said math, and you diminish this great math into calculus. And my question is, I can see that mathematics in general, even prime numbers, even natural numbers, everything about math, geometry, Euclidean geometry is God's work, is the language of God, the language of nature. But you said no, it's not math, it's calculus. So if you can play or just draw for me the distinction between math, which is the language of God, and calculus, which is a language of other God. I don't know.
Well, I wouldn't want to make too fine of a distinction there. I think it's fair to say mathematics is the language, because as you say, geometry, actually Galileo's quote was about geometry. If you really look at what Galileo is talking about, he says that the book of the universe is written in triangles and shapes. He was thinking of it as geometry. Galileo was working at a time when calculus was just being created. In fact, he was one of the people who helped to create it, he and his students. The problem with saying geometry is the language of the universe is that geometry is frozen. Geometry does not allow for change. The triangles on the page don't move around. Geometry is perfectly fine for an unchanging universe. For a universe that is rigid. If you're interested in architecture, geometry is fine. You don't want your buildings moving around too much, to say the least. So the need for calculus becomes clear when we start dealing with shapes that are not built of straight lines. If we deal with curves, like I mentioned in the Shrek example, it turns out we need calculus to deal with things like circles and parabolas. Curved shapes require calculus. You didn't learn about parabolas in geometry class. You learned about them in a more advanced class because curves are hard. All right, let me get back to the real question. Why calculus? Why is calculus so special? If you look at the laws of nature, Newton's laws of motion, Maxwell's laws of electricity and magnetism, Schrodinger's equation in quantum theory. Look at any of the most fundamental laws of physics. They are all, as you said earlier, differential equations, which is essentially calculus, ways of describing how things change, whether it's the electric and magnetic fields changing or the strength of gravity changing as we move around in a gravitational field. When you deal with change, you're dealing with calculus. And the laws of physics are written in this language, a very specific subdialect of math. It's one dialect. It's the dialect of differential equations.
And the dialect of change, and change in place and change in motion. And since physics is all about change in place in motion, so calculus became like a cornerstone in the realm of physics.
That's right. It's a part of math. You still need numbers, of course. You still have to quantify things and measure things. So you need numbers. You need arithmetic. You certainly need geometry.
You need set theory. You need a lot of things. Yes.
Yeah, but again, that's right. So I don't want to make a big fuss that somehow calculus is all we need. And we need more than calculus. We need probability theory, right? Some of the universe obeys random kinds of behavior rather than predictable behavior. So calculus does not answer everything. It's just, if you had to pick one part of math that is the most powerful, the most all-encompassing, I do believe that calculus is it. But even by itself, it's not enough. We need all of math. I agree.
No doubt about it. Now, one thing in your book that just blew my mind. Now, I knew that Newton and Leibniz didn't actually invent the calculus. They stood on the shoulder of many, many giants, including Fermat and Cardano and many others. And when you see what they had before they invented the calculus, it was, wow, they had a lot of things before. But one thing in your book that I didn't know was the work of Archimedes. And the work of Archimedes said, basically, he basically like invented the calculus himself. This is what we have. If we want to compute the area of the parabolic segment and the straight line, what Archimedes says, and this is from your book, he just like differentiate or integral it. So if Archimedes has almost had the idea of calculus, why did we have to wait over 1,000 years for the formulation?
It's a great question. It is true. I mean, in the example that you just showed there, Archimedes is representing the parabolic segment he's putting triangles inside of it. And then he puts triangles on top of the triangles like there, and he's adding up smaller and smaller triangles to approximate the curved area. This is a strategy that is the essence of calculus, building up complicated things out of infinitely many simpler things. In this case, building up a curved shape, a parabolic segment, out of infinitely many triangles of different sizes.
And this is how you compute pi.
You can compute pi. In fact, Archimedes was one of the first to give a really systematic computation of the number pi with this same kind of strategy, representing in that case a curved shape, a circle with polygons. So he had this idea around 250 BC. I'm sorry, I don't know what the year would be in the Hebrew calendar. But anyway, he's you could tell me. Anyway.
It's during the first temple. It's during the first
temple.
Yeah.
Okay. So during the first temple period.
We know that Yirmiyahu, the prophet, met with Socrates.
So Socrates is older than Archimedes. He's around 400 BC or something.
Yes. He died in 399 BC.
Okay. Yeah. So Archimedes is like another century later, and Euclid also a century later. So Archimedes worked in Syracuse on the island of what is now Sicily, in the Mediterranean. Anyway, he has all the ideas of calculus. He really does. I think of him as the creator of the first, really big advances in calculus. There were people before him who had this idea of using infinitely many simpler shapes to build up a curved shape. They were all interested in curves and geometry. Someone named Eudoxus was before Archimedes, but Archimedes was the great virtuoso. I mean, he really brought this idea to great refinement. And why, you ask, did it take another really close to 2,000 years before we see people like Isaac Newton and Gottfried Wilhelm Leibniz? And I think the big missing link is that Archimedes doesn't have algebra. Archimedes has geometry. He has ways of adding up areas, but they're very ingenious. It requires him to be one of the greatest minds of all time to do what he does. Every problem is a new problem, and it requires his ingenuity. About 800 AD, so like about 1,000 years later, we start to see algebra getting strong in the Middle East, in places like Baghdad and in Egypt, but especially in the Islamic world. They were actually great mathematicians. They got a lot of their ideas from India, who were also great mathematicians, Hindu mathematicians in the years like 600 AD and so. But anyway, that was really a big center of learning. Remember, Europe at that point is in bad shape. The Roman Empire has been, obliterated. It's so-called Dark Ages in Europe. And the Middle East is really where the action is now intellectually, in Persia, in modern day Turkey. I mean, I don't know. I've often wondered about the great Jewish mathematicians of this time. We don't hear much about them. There were some.
There were some, and some of the Arabic mathematicians were basically Persian mathematicians that the Muslim just paid them, to publish. Like it was plagiarism, but Jews were never interested in science for science. I mean, biblical rabbinical Jews were not interested in science for the sake of science. They were interested in science for the sake of the halacha, for the sake of how to worship God better. And this is why, Jews computed pi as 3, which is a very, very bad estimation. But we computed, the cycle of the moon around Earth to the 5th decimal place. Why? Because it has a very big implication, whether you eat on Yom Kippur or not. So if the mass has anything that has any halacha implication, so we are going to straight into, and we are going to dig further and further. But
interesting.
Yes, but if math has no real world halacha implementation, it doesn't interest.
There were also great Jewish architects who helped with temple construction and other buildings around the whole empire in the era when they were enslaved people. There were Jewish mathematicians who helped with architecture. But anyway,
let me give you my theory. And my theory said, and it's not my theory. And the idea is, when they encounter a right angle, like a 1, 1 and the square root of 2 triangle. I don't know how you call it.
Yeah, that's clear what you're describing.
Equilateral.
It's called a right triangle. Yeah, it's called an isosceles right triangle.
Isosceles right triangle. Okay.
Yeah.
And they say, okay, so the square root of 2 is irrational number, and by irrational number, we say there is no amount of one thing that I can put in 1, and then I can put in the 2. And I would say that what stopped the Greeks from going further, and they were extremely smart. Whitehead was actually right. All Western philosophy is footnote to Plato, because what stopped them was a philosophy. They believed that God created Earth with natural numbers. And if God created the Earth with natural numbers, so irrational number is something that you cannot grasp. It wasn't their intellectual, it wasn't the IQ that stopped them. It was their philosophy. The philosophy didn't let them see beyond the right triangle. And this is why, you have Achilles and the tortoise. You have like all these infinitesimal paradox, the Zeno and the Arrow paradox. They had it, but they had a bad philosophy to describe nature.
Well, this is an interesting argument you're making. I don't think I agree, but I've never heard it phrased this way. I mean, to me, the lesson with the irrational numbers, which was discovered by Greek mathematicians, the existence of irrational numbers, as you described, from someone in the school of Pythagoras, right? The Pythagoreans, we're not exactly sure who. There are legends about it, but one of the Pythagoreans discovered the thing that you mentioned, that square root of 2 is not the ratio of any whole numbers. But to me, the great lesson that the Greeks took from this is that you should not trust numbers. You should trust geometry, because the length of the diagonal is perfectly clear if you just look at it. And so they came to the idea that geometry was more powerful than numbers, that you could represent quantities with shapes rather than whole numbers. And so that's why you see this obsession with geometry in Greek math and an avoidance of what became algebra. They do their algebra with geometry.
And even algebraic questions or algebraic problems, like greatest common divisor in the elements, is presented as a geometry problem.
Right.
Not an algebra problem. So
no.
And I think that we agree. So I agree with you, but I think that it doesn't say that my theory is not correct. So
your point, but you think that this limited what they could do. And I don't think it limited them very much. They developed a heliocentric theory of the universe. I mean, Aristarchus, long before Copernicus, proposed that
this is a great story.
That the Earth goes around the sun. And now he was not widely accepted.
And computed the radius.
Yeah, that's right. And there were estimates of how far the moon is from the Earth, and very accurate, really surprising. So they did a lot. They really did a lot. I think the main problem was that the Greeks got conquered. They got conquered by the Romans. A lot of the trouble I would lay at the feet of the Romans, who were busy conquering all kinds of intelligent people in the Middle East.
Okay, we just needed more time.
Greeks.
Maybe. Okay.
I think of the Greek, the Romans are busy conquering and enslaving and murdering people, including the Jews many times. But many other people all over the whole world. I think the problem is the Romans, not the Greeks. I think the Greeks would have done just fine if they were left alone. I mean, it's not like they were so sweet either. They did a share of conquering on their own when they had the power.
Okay,
anyway.
So let me move on. This is great, but let me stay focused. I'm sorry.
Yeah, let's talk about the book.
I want you
about
to stay focused. Now, I ask many math teachers about the questions that I'm about to ask you, and I never got a decent answer. So what we are going to do now is to go into the derivative of x squared, which is going to be 2x, and this is x plus delta x squared minus x squared divided by delta x, blah 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 blah. And now we have 2 delta x times 2x plus delta x divided by delta x. And then what we are going to say is that we are going to eliminate delta x over here, and then we have 2x plus delta x. And then since delta x is very small, we said that it's 2x. And this is why the derivative of x squared is 2x. But if delta x is not equals to 0, so 2x plus delta x is not 2x, is approximately 2x. But if delta x equals 0, you cannot divide by delta x. And my question is, and I posed this question to many math teachers, why this is equal and not semi-equal, not approximate equal? This is equal, but the math doesn't make any sense.
Well, you're right that this is a very difficult point. It was historically a difficult point in the invention of calculus. I mean, to just say it in this, you've put your finger on a crucial difficulty. Is delta x 0 or not? If it's 0, we're dividing by 0. If it's not 0, it looks like calculus is only approximately true. And what is the answer? How do we get out of this? It's all having to do with this concept of the limit. The math that you show on the page has that expression lim, L-I-M, limit as delta x goes to 0.
This is the limit.
Yeah, so we're defining the derivative as the limit as delta x goes to 0. We do not set delta x equal to 0. It's never 0 in this calculation. That's why we can divide out delta x in that second line. Delta x over delta x, it's not 0 over 0, it's some number over the same number, so we cancel it. It's not 0. And then we have to understand what it means to think of the limit. So it's sort of like, I mean, to say the limit as delta x goes to 0 means we think of imagining delta x getting closer and closer to 0, but it's not ever going to be set equal to 0. So if you ask, what is that expression, 2x plus delta x, what is it approaching as delta x gets smaller and smaller? Think of like walking towards a wall. You're approaching the wall. That expression, 2x plus delta x, is approaching 2x. That's defined as the derivative, the limit. You don't set delta x equals 0. You ask, what are you approaching as delta x approaches 0? That's the way we get out of it. We don't set delta x to 0. We only consider a limit. And it's because that's how you have to define a derivative in modern math.
You cannot, the question is, let me put it differently. The question is correct. And the only way to go around the question or solve the question and say, listen, I need to define a new term, a new creature in math called the limit. And the limit is going to take care of this very problem. And indeed, this is a very serious problem. And many people say that, Newton and Leibniz had this great deity, divine epiphanies that they ran forward so fast that, 100 years after Cauchy and Weierstrass, walked very, very slowly. And there was one word that they were extremely afraid of, and the word was infinity. And this is why when we teach math, we teach, the definition of limits is very, very peculiar. Let's say that C will be positive as long as we want. And the idea is they didn't want to inject infinity into the equation because one cannot grasp the idea of infinity until Kronecker or Cantor. Would you agree that
well, yeah, I like it. I think what you're saying is pretty historically accurate, that the earliest practitioners of calculus, so leaving Archimedes out, let's talk about what we would today call differential calculus, these ideas relating to the derivative, the rate of change. So yeah, Newton and Leibniz had a lot of trouble figuring out what they were doing logically. Like, are they setting delta x equal to 0 or not? So Newton tried to think of it in terms of motion. He actually thought, he had a very physical picture of what he was doing when he was taking a derivative. Leibniz used the concept of infinitesimals. He tried to think of some kind of number, delta x. Rather than delta x, he wrote little d x, which is supposed to be very close to 0, but not 0. And he knew that it was hard to make sense of this. He understood your question. He didn't have a good answer. He considered it a kind of fiction, like a game, that this works. I don't really know how to justify it, but I'm just going to do it. And later mathematicians, like you said, Cauchy in France and Weierstrass in Germany, said this is not acceptable. Math is supposed to be logical. It's supposed to have rigor and proofs. We need to make this as rigorous as Euclidean geometry. And the difficulty was to figure out what is an infinitesimal. And they never really figured it out. So they got around it by this really awkward construction of a limit. And today students are taught this construction very quickly usually, and without an appreciation of the 200 years of difficulty that forced this concept to be invented. So when a beginning calculus student is taught the limit, like you said, you had to ask your teachers many times, it's really confusing. And so I tried to explain in the book why we were led to the idea of the limit, why infinitesimals are actually what we want. It's just that they're so hard to make them logically sensible. But that's the intuitive idea. But infinitesimals or the related idea of infinity, very problematic. And that's, calculus used to be called infinitesimal calculus. Then infinitesimals came to be seen as bad or, sort of taboo. You had to get rid of the infinitesimals after Cauchy and Weierstrass. So we don't call it that anymore. But that really is the intuition.
I think that there is a very big or nice lesson that many people think that math is all about rigorous proof and etc. But it's not. There is only one part of it's like the second part. The first part, like I think that you said it, is a creative, intuitive part. Spark of a genius. Speaking with the gods. I don't know how you want to call this, but Newton and Leibniz had this intuition that this is true, and they had no proof whatsoever. And in fact, it took like over 100 years to make all the rigorous proof accessible. But math is not about just being very square and everything has to be QED. It has a very big part of creative, intuitive thinking. Would you agree?
I totally agree with that. And that was one of the things I wanted to get across to my readers, that there is, like all creative work that people do, or all successful work that we do in any domain, there's imagination, and then there's technique, or the careful part of making things clean. But when you think of a good new idea, it's usually kind of rough at first. The act of creation is messy. You have to make a mess and then you clean it up. And in our traditional math teaching, we emphasize being clean, but not enough about getting dirty. You have to get dirty before you get clean if you want to make progress. And so I tried to show that through many historical examples. That's the truth of how it's been done, and it's still being done today. I mean, as a working mathematician, I can tell you, I never give the proof first. I have to study all kinds of examples. I see examples in nature. I use the computer to give me like experiments that I can then, it takes a long time to prove a theorem. You have to have a lot of real world or numerical examples before you know what's going on.
But by the way,
yeah,
sometimes you just look at something and say, it feels correct, it feels right.
That's also true.
Yeah, like in the work of Ramanujan, I think, I hope that I said
yes, Ramanujan was like that, yes.
Ramanujan had this feeling for math, yes, it should be correct. I don't know how, but he had like a very strong intuition, and he said that he got it from the gods. He said it directly to Hardy, the gods. And Hardy was... Poor Hardy.
I think it might be interesting to talk about that for 1 second. I mean, I know you want to stay on the main thread, but
this is a
math.
Scientific podcast. If you want, to steer away to other...
Well, I think
I will be more than happy. But this is
I think we should talk about God a little bit in this context, because when I was writing the book, my wife said to me, I noticed that there's a lot of God. Like, why is there so much God in the book? I hadn't even been aware of it. Not only in the original quote that we talked about with Hermann Woke and Feynman saying it's the language, calculus is the language that God talks. But later people like Johannes Kepler, the great astronomer who figured out the laws of planetary motion, before he was an astronomer, he was planning to be a minister, a Lutheran minister. He was training to do that. You talked about, the halakhical aspects of math.
Isaac Newton
was very religious. Newton was very religious. So was Galileo, actually.
By the age of 30, and for the last 30 years of his life, he just focused on interpreting the Bible, interpreting the Zohar. We have some scribble of Hebrew writings by Isaac Newton that is trying, to get to interpret the Zohar. If you know, there is a context in the Zohar. It says Taf Chazi. It's Taf Aleph Chet Zayin Yud. Bo tir'eh. Come and see. So we see the writing of Newton, Taf Aleph. He was a very devoted. Yes. He had many Hebrew writings that belongs to the Hebrew University in Jerusalem.
I don't know about that. Interesting.
But
so I think it's part of the story. And of course we know Einstein. Yeah, a lot of them have this kind of Spinoza God in mind, like later people like Einstein. But Newton and Galileo are talking about the traditional biblical God. They think they are revealing the works of God through the science that they're doing. And they don't see any conflict with being devout and scientific. So it's a part of the story. It's not universal. There are others who are not interested in God. So it's not like all the mathematicians are, but it has been important for many of them.
I think that the language that gods talk sell more books than the language that nature talks. So I won't say anything. I can't take anything. If you believe in the Spinoza God, so basically Deus sive natura. So you say, okay, the laws of nature are fixed, and then you can ask, if you want, what caused the laws of nature to be fixed? What caused the math to be explainable? Let me give you a quote that I saved for later on, a quote from Paul Weiner, the Hungarian-American physicist. The miracle of appropriateness of the language of math for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. I start with the miracle. And so this is basic. The unexplainable thing about math, that it is explainable, that what you come up in your own mind, that has no restriction in the real world, number theory. Number theory is a great example. Number theory is just in the mind of the originator of Feynman and all the other things. But why? number theory represents something unique in nature. How is it possible?
That's a hard question. I like that question myself. My whole life as a mathematician is kind of due to an epiphany, and I mean it almost in the religious sense, that I had as a young boy, that I felt this when I was doing my first science experiment on a pendulum swinging back and forth, and
like
noticing that it obeyed. Yeah, and I didn't know about Galileo. I was just 13, but the teacher had us do this experiment. And I started to discover as I was graphing the dots on my graph paper that the pendulum's period as a function of its length, the time for 10 swings versus the length of the pendulum, obeys a little algebra formula. And I thought it was very spooky. How does this pendulum know algebra? Like the law, because as a little kid, I didn't know, what do they mean, a law of nature? Well, this was my first encounter that nature's behavior, the swinging of a pendulum, is governed by the algebra I was learning in algebra class. And that seemed weird. And I got a kind of creepy feeling like on the back of my neck, which I think was a kind of experience of
religious thing.
Of a religious feeling.
Yes.
And again, I don't claim, I'm not a religious person myself, but this is my religion if I have a religion.
You need to redefine, I think, something, but the idea that the motion of the farther galaxies is obeyed by the same laws of physics that obey, the blood pressure in your finger. How is it possible? Why on earth should the laws of nature should be universal? This is like a very tough question to grasp, even not to answer, just to grasp. Wow, this is incompatible. I don't know if you've said that.
Yeah, something like that.
It's very big. I don't know.
Yes. There's another aspect of this mystery that I think is interesting. I don't have an answer for your mystery. This is the great mystery. I mean, Einstein was puzzled by this mystery. You mentioned Eugene Wigner. I mean, no one has an answer to this.
I want to add, with your permission, that religious people still don't have the answer for this. Okay, no? I can say I don't believe in the Spinoza God. Okay. I believe that God gave or set the rules of nature, and this is what we should learn. And sometimes there is a slightly shift from the laws of nature, but in any case, the laws of nature this is what governs the universe. Okay, but what you should learn, and this is what Maimonides say, you should learn what is Maaseh Bereshit. You need to learn the physics. You need to learn how God operates in the world, and he operates via physics, via biology, via economics, via chemistry, via everything. It's not that you can know how to build a car from learning the Torah, from learning the Bible. Okay? You need other aspects of human endeavor, of human creation, to build, to conquer. And this is why math is so important.
We agree about how important it is. I like your comment from Maimonides. That sounds right, that we should try to learn wherever we believe these laws of nature come from. They are worth learning and studying and devoting time to, even for people who don't like science or don't have much use for it in their ordinary life. I hope that they can appreciate how cool it is that this is the way the universe works.
So what can I get from your book? Because if I'm in the humanities and I want to summarize your book, and this will be an unfair summation, I would say the calculus is the art of taking a big complex problem and breaking it down into smaller pieces. And this is like the first part of calculus, which is called differential calculus. Just take a big problem and slice it down into the smallest parts of pieces that you can think of and try to solve each problem separately. And then this is integral calculus, which is much harder. You need to combine all the problems together and go back to the original problem. Okay? So this is like calculus for dummies.
That is it. That I agree, and that's what it took me years of working on this project before I saw that. In the end, I called that thing that you just described the central idea at the heart of calculus. Except I want to add one thing to it, which maybe you're kindly letting me add, like you could have mentioned it, but you're letting me mention it, which is calculus has a particular strategy. It's not just breaking a problem into smaller parts and then solving them and putting them back together. It's to keep going with the division step, make them smaller and smaller and smaller and do it infinitely. That's the crazy idea in calculus, that if you subdivide a problem infinitely finely, whatever that means, that's the hard part. If you go all the way down to the infinitesimal, everything becomes crystal clear. That's when the problems become easy. No matter how complicated the thing is, if you chop it up infinitely fine, it will become easy, you can solve it. And now the hard part is putting all those infinitely many tiny pieces back together. That's the great challenge. That's the challenge of integral calculus. That's the challenge of solving differential equations. That's what's taking us, well, that's why we need computers nowadays to solve them. To solve calculus equations. But that strategy over and over again has given us the modern world. So yeah, it's the single biggest idea behind calculus.
Let me tell you a story. And I loved quantum mechanics. Again, I'm not smart enough to learn quantum mechanics, so I'm just an engineer. And I read all this and popular science books about quantum mechanics, about Schrödinger cat, and about the Heisenberg theory, about everything. So I knew everything there is to know if you're a non-scientist. And then one day I said to myself, you should visit a quantum mechanics course in the university. Just, for the sake of, you love quantum mechanics so much, go to quantum mechanics part 2 and just, stay there. And there, I think I stayed there for 3 weeks. There was nothing from the Schrödinger and the multiverse, multi-world, only brackets, where, full brackets on the wall. And then for the first time, I figured what's the difference between like the popular science understanding of something and the real understanding. Because when you say, okay, you just chop something into smaller part, I did calculus, I teach calculus. Okay, it's a very, very nice way to look at things, but this is not what we do. It's like the brackets and the Schrödinger cat. You can go from the brackets to a Schrödinger cat, but this is a long, unintuitive journey.
It's true. And that's the challenge for a popularizer, that how can we tell the truth knowing that it takes years of training and very difficult work? It's not, quantum mechanics or calculus, these are not easy subjects. They require a lot of concentration. They were developed by some of the greatest thinkers of all time. How could they be easy? They're not easy. So when we do popularizations, we make them sound easier than they are. I think an intelligent reader knows that. But the trouble is, if we only teach the details, like you got in your 3 weeks of quantum mechanics, or like most people would get in a typical calculus course, they won't see the big picture. And all I'm trying to do is give people the big picture of calculus and enough love of the subject, enough inspiration that maybe they will have the patience and the energy to sit through the long course. Because you're right, you can't really learn it without sitting down and doing hundreds of problems and attending many lectures and thinking and getting stuck. But it helps to be in love. If you're in love with the ideas, because you know where they're going, you know what the big picture is, you might be motivated to really put in the effort to learn. And that's what I'm hoping to do. And I think that's what the popularizers writing about Schrödinger's cat, it's one of the great ideas, right up like I say, quantum mechanics, calculus, evolution. These are very big, subtle ideas that you can read popularizations, and hopefully that's enough to get you motivated to learn the real thing.
So let's not talk about, the uneducated humanities popular or audience, but talk about your students, students who take graduate students or not graduate, undergraduate students in math, physics, engineering, chemistry, biology, etc.
Mhm.
And there was a recent article from Jonathan Haidt recently. I don't know why. And he said, we have a different world of students. Our students is very different from the students like 10 or 15 years ago. And maybe you should, or we should, as scholars, as professor of math, steer the syllabus or change it a little bit so we can encapsulate or, introduce all this history and all these great ideas of calculus, because it is very, you said yourself, calculus is so intense, there's so much to cover, so much to learn, and and we cannot see the forest from the trees.
Mm-hmm.
Would you say
so
that
you're suggesting
in 3 years, in 5 years, we will see like a different syllabus of Calculus 101 that will also have time for the history and the motivation?
I doubt it. I don't think so, because everybody's in a rush. Modern society moves fast. Think about your own training. You said you described yourself as an engineer. Engineers are most of my students. I teach calculus from a very applied perspective. And so my customers, I shouldn't call them that. It's not a market. It's they're students.
It should be.
They may think they're customers because they're paying. They do pay. But I still think of them as students, and they're physicists and engineers and some mathematicians, and some humanities people too. But the point is that like an engineer needs to learn a lot of engineering in addition to learning math. And they don't feel that they have time in their schedule to spend a whole course or even a few weeks on what they might see as soft, history and motivation. And I don't see it happening. I think it would be nice if maybe even in high school, people could learn what these subjects are. It's a tough problem in education. It's the difference between appreciating something and mastering it. Like I would like to appreciate opera, but I don't want to sing opera. I'm not that interested, like to become an opera singer, but I would like to understand opera or classical music better without training to be a classical musician.
But would you agree but can you agree that you, without being a little bit trained in opera or educated in opera, you can't fully appreciate opera?
No, not fully, of course. You wouldn't fully appreciate it, but you might appreciate it enough.
You can't fully appreciate it.
I think that's the problem. I think we don't give them even a drop of appreciation for math right now. It's all business. Here you are, you're now taking algebra. Let's get down to the business of algebra. Or now you're taking calculus. Let's get serious and define the derivative on the first day. I think we're out of balance. We need a little bit of, I don't know what to tell you. I mean, the way I teach it, even when I'm teaching it to my professionals, to future mathematicians or engineers, I still tell the stories. I still try to capture the human struggle. Why were these ideas invented? What do they do for us? I still show applications, in medicine or biology or whatever, or physics. I think it's like this, that different people like different things. Some students like history. Some people hate history. Some people like logic. So, I mean, I try to emphasize the beauty of the proofs, the history, the applications.
But some things cannot be learned without the context of history. Let me give you an example. If you want to teach logarithms. So
yes,
if you don't understand what logs are all about, say, why do I need it? Because I have a calculator. But when Jean-Pierre invented the logs, he didn't have calculator. So when you understand, the motivation behind logs, and when you understand, this, how you call this law of logs when everything starts with one? Benford law. So
the Benford law, yeah.
Benford law. So again, I didn't understand, why are we learning logs? We have calculators. Why do we need it? And they didn't tell, the missing part of the puzzle. This is the calculator of ancient times. And this is, what changed everything. This is what I'm doing right now. I substitute.
Well, I don't know. Would that work? Maybe. I mean, if a student was told this, they needed logarithms in the year 1500 because they didn't have calculators. Okay, but we do have calculators now, so why do I care?
This is another but very good question. This is a very good question.
I mean, my answer would be you need logarithms because you need a vocabulary to understand the world around you. If you know what a logarithm really is, you can understand, for instance, how human hearing works. That why is it that when I play a note that is double the frequency, it sounds 1 octave higher. And then if I double the frequency again, it only sounds 2 octaves higher. Like, why does psychological perception of music go up in additive steps when frequencies are going up in multiplicative steps? And the reason is because human hearing is logarithmic. If you don't know what I mean by logarithmic, you will not understand this very deep thing about psychophysics, about perception. Or if we talk about pH, for acidity, or we talk about the Richter scale for earthquake sizes. If you don't understand logarithms, you're kind of an idiot. You can't understand any quantitative thing about the world around you. Of course, now in the time of the virus, you better understand logarithms and their inverse exponential growth. So that would be my point. It's not that yes, of course, there's an exponential and a logarithm button on the calculator, but you need the mental framework. You need the concepts to be part of the modern conversation. Otherwise, you're a dummy. You're just sitting there. And, that's the real, and the same thing with calculus, honestly. Like, do you want to be a dummy? But basically the answer is yes, I'm a dummy about some things. I don't understand like intricate stuff about the Constitution. Let's say in the United States, there's all this political stuff about the Constitution. Did I ever study constitutional law? No, I didn't. I was busy training to be a mathematician. So I'm kind of stupid about basic things about the law. I wish I understood them. I should take the time to learn.
You just need to
There's a lot to learn.
The Federalists. In Israel, there is like a big conservative new movement that they read the Federalist. Israeli people, Israeli read the Federalist, and it's so funny. Immersed in the Federalist. Many Americans don't read the Federalist right now.
No, of course. I don't even know what you're talking about. Is it a newspaper, or are you talking about ancient writings?
The Federalist, the writing of Hamilton.
Yeah, the Federalist Papers.
The Federalist Papers, I'm sorry. Yes. Now there is a Broadway show, Hamilton.
Oh, yes. Okay. That's right. That's how we're learning about Hamilton.
The Hamilton. This is how we learn about Hamilton. So with your permission, let me ask you two final questions. One, which of Feynman said in his book, Surely You're Joking, Mr. Feynman, that his math teacher once told him, listen, you should read Calculus for the Practical Man. And Feynman said that this book changed his life, and this is where he learned to differentiate under the integral sign. And I have never came across this book. I tried, to buy it. It's unavailable. Have you ever read or opened this book, Calculus for the Practical Man? Because Feynman said this book changed my life.
Well, all right. I think there may be two books that we should talk about. Feynman, I believe, refers to a book on advanced calculus by an author named Woods. So he learned about differentiating under the integral sign in the book by Woods, I think. I do have read that book, and I could send you a copy, a PDF of the chapter in Woods about differentiating under the integral sign. But Calculus for the Practical Man is a famous book that was popular in Feynman's era, and I have not read it because I learned calculus from a different source. I didn't need to read Calculus for the Practical Man, but I think it's a pretty good book from what I hear. So yes, people I'm surprised did you not find it on the internet? There's no copies?
No, now I see that there are copies, but when I first read Surely You're Joking, Mr. Feynman, it was 20 years ago, and then I searched, and then it wasn't available. But now I see it's available on Amazon. So
it's probably worth looking at.
And he said the differentiated under the integral sign was a trick that we used over and over and over and over again.
It is a good trick. It is a good trick. I teach it to my own students. It's nice. And I usually give them the excerpt from Feynman's book where he talks about that trick.
That he used it over and over again.
It is a good trick, yes.
But many people don't, it's not part of the formal calculus syllabus. You don't usually learn it. Would you agree?
True. Yeah, it's true. It's not taught very often because, as Feynman points out in that discussion, there's another technique that we use something in a subject called complex analysis. There are methods in complex analysis that everybody learns once they get advanced enough that solve the same problems that you can do by differentiating under the integral sign. So that subject has tended to fall out of the curriculum, but it shouldn't. And you know who uses it? Physicists use it all the time.
Yes.
If you had continued in that quantum mechanics course, you would see physicists differentiating under the integral sign left and right. They do it all the time.
I think that physicists use all aspect of math that can be, there is something called linear derivative. I think that, that the guy who invented it said, okay, I invented something that physicists will never use. And they use it, okay? So many physicists use everything because nature speaks in the language of math. And again, we don't know why. Now, another question, Patrick Winston from the MIT said that he used to, in MIT artificial labs, in the 60s, they had a program that calculate integrals, but not, how you say it, like there is like a, as the previous function. I don't know how you say it in English. There were two kinds of integral. One that, resembles the area, and one that this is like a previous function. So I don't know how.
Yes, I know. So
what
so
of the terms in English?
The words are, the definite integral is the area, and the indefinite integral is what you're calling the previous function or the antiderivative.
Would you say
indefinite integral?
Okay, now we can solve definite integral in problems in cases like Monte Carlo simulations and all sort of things. But would you say that solving indefinite integral indicates intelligence?
Oh, well, of a certain kind, yes, sure. I mean, it takes some kind of cleverness. I used to love doing that as a high school student, to have a hard integral to calculate and find the indefinite integral, because it's a certain style of thinking. It's where you need to get from here to there, and many steps are required, and they're not obvious. I also, when I took organic chemistry, it was a similar thinking pattern to do organic synthesis. What sequence of reactions get me a desired product? It's a kind of intelligence that requires connecting the dots by a non-obvious path. So Newton, you can see in Newton's own writing that when he was showing off to Leibniz in their correspondence how much better mathematician he was than Leibniz, he would send him difficult indefinite integrals. And he was much better mathematician than Leibniz. And Newton could do these, and Leibniz, but also Leibniz was kind of a beginner. Leibniz was doing this he only started math like a few years before he invented calculus. He was very fast, but he was a beginner. Newton had an advantage of about 10 years on him. Anyway, yes, it's a kind of intelligence to do that. Nowadays, we do them in the computer. You mentioned Stephen Wolfram. If you ask Wolfram Alpha or the bigger program, Mathematica, they can do any indefinite integral that can be done, as far as we know.
They can solve e to the minus x squared.
Yeah, that's a good hard one. Yes. That one is more interesting. Right. There's a special function that will give you that one.
Yes. Patrick Winston once told the story that one of his students approached him and said, listen, I don't believe artificial intelligence exists. And then he showed him the software that solves indefinite integrals.
Oh God.
And then the student say, okay, now I believe. And then, and just a second, it's not the end of the story. And then Patrick Winston said, I made a fatal mistake, and I explained him what the program does. And after the long explanation, the student say, I changed my mind. It's not intelligence. It does exactly what I do when I solve integrals.
Yes, it's an interesting question from a deeper perspective. Do we consider that intelligence? Is your calculator intelligent? It can do big multiplication problems. better than you? Is your calculator more intelligent than you? It is at that, I mean, that seems sort of trivial to call intelligence. The way that artificial intelligence is going, as I'm sure some of your other guests, actually, I see you had a guest talking about explanatory artificial intelligence.
Yes,
I mean, that's really the frontier, right? Making an AI that can do common sense things. That's the hard part.
But many AI systems can do common sense. And it's like, I know it's like what is the definition of intelligence, because there are two types of intelligence. So like Daniel Kahneman said, there is system 1 and system 2. So if I look at your face, I can instantly know approximately what you feel. And this is a very, very tough task to do, because we don't have emotion recognition. We have facial recognition, which is extremely different. You can smile, but I don't know. You're American after all, so you always smile. Okay,
I'm always smiling.
Yes. So I don't know what you feel. I don't know what you feel right now because I have facial recognition. But I think that we as human, we have emotion recognition, which is something extremely different. But if I want, to multiply 2 digits by 2 digits, it is a very, very tedious task for a human being. But a computer can do it instantly. But the idea of intelligence is take something that it's very obvious to us, like understand a joke, like understand emotion, and try to put it in the computer. Computers can think in system 1 much faster than we do. But can they be intuitive or creative like we do? Many, if you like, if you're going to focus on one task, computer can do it. If you're going, task like, I don't know, how you call it, Raven matrices, they can do it. If you want how to write a story, computer can do it. But if you want to know artificial general intelligence, this is a tough one.
That seems to be the tough one. Yes. So I don't know how I should have answered the question about the indefinite integral. It seems like it's a very circumscribed intelligence to be able to do that. But it is actually, speaking now in terms of education rather than AI or computer science, we should recognize that students like doing these kinds of tasks. If you can train someone to do indefinite integrals, they get a feeling of satisfaction. We talked earlier a lot about beauty, the beauty of math, the beauty of calculus. And I think beauty might be overrated. What a lot of young people like is the satisfying feeling of getting the answer. So as a teacher, like when I work with my kids who are now in their 20s, but when they were little, they never said math is beautiful. They said, I like it, that it worked. The answer came out right. So even though we might want to dismiss these kinds of calculations as kind of, trivial, or your calculator can do it, or Wolfram Alpha can do it, it's part of mastering the subject. And it's very satisfying for a beginner to learn how to acquire those skills.
Now, about the education system, I think that we need to quote Tom Lehrer. He said that in the new math system, they want you to understand what you're doing rather to get the right answer.
Yeah, Tom Lehrer was funny.
Now, this is my last question. And
he was Tom Lehrer was a mathematician.
Yeah, of course I know. Of course,
math professor.
Plagiarize. Yeah. I got a friend in Minsk who had the friend.
Yes. I see you know his work. Very good.
Yeah. I tried to translate the Element song into Hebrew, but it was too tedious. It was
hard.
Super. Okay. Now you are a full-time professor. Your Google Scholar is much more impressive than mine. Let me put it this way. But you also write for the general public, and you have students, and you are very busy man. And some of this channel is also about creative and productivity, how to be more productive. And as a professor at Cornell University who writes like popular science book and has graduate students and does the research in many aspects, can you give me a tip of what is your best tip of productivity? What makes you, in your opinion, so productive? And I know you will say you are not productive enough, but okay, blah, 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 blah.
Okay. Well, a few things have been helpful to me personally. I don't know that they would work for other people. For writing, I like to use the dictation function on my phone. That is, if I start writing by typing, I find that I want to correct it immediately. I start deleting as fast as I'm typing. I just keep criticizing myself. And so I need a way to turn off my censor, like that is. So what I find works well is if I walk around with my dog and I just talk to my phone, and I'm saying a lot of garbage, just stupid stuff, but occasionally I'll say something good or sensible or interesting. And then I can delete all the other bad stuff and just keep the good parts. I think using dictation for me is very helpful in writing. Another piece of advice is
just a second. This is a great advice. Just a second. Just a second. This is a great advice. This is a great advice. Wonderful advice. But I need to ask you something about your advice because I want to take it with my both hands. When you dictate, you have like a notion of one chapter, or just or just like in the beginning, it's the early drafts, or you also do this procedure when you need to write I need to write the chapter about Archimedes and I'm going to do it. So I pick the smallest thing that I can think of. I would not do it for a whole chapter. That's insane. It's for a very small piece. So I might talk about where Archimedes grew up. Where is he from? And then I would do some research by reading History of Math, like that David Burton book that we were looking at earlier. So I get all the various writers and experts in my head, if it's an area I don't know. And then I go outside and walk around the neighborhood with my dog and talk to myself about what I read. Because I don't want to plagiarize the writers that I just read. I don't want to copy their words. I'd say it to myself. Another example would be if I suppose I'm trying to explain Zeno's paradoxes. You mentioned Zeno earlier. So I don't need to read a historian. I know Zeno's paradoxes. I've thought about them for 40 years. How would I explain Zeno's paradox of the arrow, let's say? So then I just start walking around and I explain it to myself in the dictation. And then my dog has just come in. Then I would do it again. I might think I don't like the way that sounded, and I'll just talk to myself for another 15 minutes and try it again. I might do it 10 times. The point being that it doesn't cost you anything. It's free whereas typing, I'm a very bad typist. So for me, typing is painful. And I also tend to see what's in front of me and then I want to edit it. Whereas with dictation, I can't see anything. It's in the phone. I can't edit it easily. I suppose I could, but it's not easy to edit, so I don't. I just leave it there. The larger point here is that the creative process, I mentioned earlier, you need to make a mess and then clean it up. For me, dictation is a way that I can make a mess. My tendency is I like editing. I want everything clean. I need some crutch to make things messy. Me, dictation lets me make it messy. This is a great advice. One more thing regarding your advice. What about the outline? When you start your book, okay? Now I can, because it's so fascinating to me, okay? Like I have this book, okay? In what phase, do you have this, these chapters from the very beginning, or just after, like in the very end, you get the outline? When do you have the outline of the book that we need to put here?
Yeah. Well, that has been different for different books. This book, I didn't actually know what the structure was exactly. I did 3 drafts of this book. It took me a really long time. I would give it to my editor, and then the first time I wrote it, it was too much about history of math. I found myself writing a lot about history. And he said, the editor was helpful and said, I think it's very nice, but I had this one chapter where I had a discussion of HIV and how calculus helped doctors make HIV into a manageable chronic illness instead of a death sentence. And he said, wouldn't it be great if every chapter had an application like that compelling? And I thought, that's the book I meant to write. I wanted it to be very applied. Why did I write so much history? So then I rewrote the chapters to put applications, like we talked about Shrek and computer graphics. I thought, I want to show that. So I stuck that into the Archimedes chapter and put applications like that in every chapter. And that was the second draft of the book. And then the editor said, it's great. I wish there was one principle that went through the whole book, that tied the whole book together. And then I realized, oh God, that's right. It needs an arc. It needs a central thread. And then that was when I discovered the thread that you talked about, that calculus is about making problems simpler by chopping them into smaller parts. And so then I rewrote the book again with that thread going through it. So the outline kept changing each time. And so I don't find it realistic to have the outline at the beginning and then just do chapter by chapter. I think it's helpful to be a little bit looser and surprise yourself, because then sometimes, but it's painful. I wrote like 3 books instead of 1 book. So there's a lot of, it feels like wasted effort, but you don't actually know what you want to say until you say it and then you correct it.
I'm currently in the writing of my 5th books. My 5th book, and it's all about artificial intelligence, but not from the math perspective, from the philosophical perspective, the Chinese room, and what does it mean? Even if you're an observant Jew, can it replace God, or can it replace like the gist of the human nature or the human being? So I'm still stuck, how should I do it? But I think that the dictation advice is great. I am going to take it with 2 hands.
Try it. Yeah, just get yourself a first draft, and then you'll see what you don't like, and then you can work with that.
This is great.
Oh, good. I'm glad you find that helpful. So what is your own strategy? Do you usually use an outline?
No. I use my wife. My wife is my brutal, ruthless editor. And yes. I had a book called Enlightenment version 2.0. And it was about, the importance of learning in the 21st century, and why learning hasn't been so important up until now, and why schooling hasn't been so unimportant up until now. And I learned, and up until the very recent draft, I thought that I'm going to name the book, How to Think. But then my wife looked at all the draft and all the chapter and said, okay, you should organize it differently. And wow. And it was like a puzzle. Now everything was fit, and it was a great thing. I also read a book about intelligence, which it was like 10 unpleasant facts about intelligence. And then I changed it a little bit. But now about artificial intelligence because I want to give the beauty of math in the context of artificial intelligence, what gradient descent is, what matrices are, why matrices are so important, why gradient descent is like the cornerstone of any optimization problem So how should I go deep, or how should I go to make it accessible to like a large portion? And I write in Hebrew, so my audience is, to start with, is not so big, okay?
Yeah, I sort of accepted at the beginning that I don't know how to organize this. I just knew that there were certain elements I wanted in the book. And then I would just try to make, like that old saying about the longest journey begins with a single step. I just thought, just make a little step on each topic, just say something, and I'll put it together later. Just generate enough raw material. And it was not a foolproof method. I should say, what is the downside of this method? By not writing to an outline, I didn't end up writing the book I intended to write. A lot of the book is missing. So you mentioned Cauchy and Weierstrass. You'll notice they're not in the book. where are they? In a traditional telling of the story of calculus,
they are missing.
They're totally missing, and other great people are missing. Riemann. I mean, Riemann is a fantastic mathematician, and there's good stories about Riemann. Where are all those people? Well, I ran out of time and I ran out of energy. So I had intended to have them all in there. Cantor, what about Cantor? I mean, if we're talking about infinity, how can you not talk about Cantor? So, well, I didn't. He's not in there. So it ended up being a different book than I intended to write. And
by the way, the famous quote by Chronicles that God created the natural numbers, all the other is man created. So this is a great quote. But yes, again. But you know, I ran out of time. This is great. Like you promise your publishers that you.
I did.
Okay.
And I did. And also it was a very big hardship on my family. Working on this book made me difficult to be with. I didn't do a lot of things for my kids or in the house that I should be doing. And they gave me a lot of space to just work. And I was often in a bad mood because there were problems. The book wasn't working the way I wanted it to, or I was getting tired, or I would have to get up at 4 a.m. to work on it. So it was a very hard project. And I don't know if I would ever write another book again. It was very hard.
I totally understand you. And I know, and this is the same with my wife because my wife is so supportive in the context of everything. I am also a magician. So
yes,
this is like an art. And there is a great mathematician called Percy Diaconus.
Oh, yes. He's great. Yeah. Percy Diaconus.
Percy is great. So, and now another advice that you wanted to give about
other advice about being productive. Yes. Well, email is a problem. I mean, I guess I would talk about email and time of day. But let's talk about time of day. I think different people function better at certain times of day. I have learned that if I work when I wake up, I'm pretty good. So I try to change my schedule. Like if I'm teaching, I will do all my classes in the afternoon. And I keep the morning, say from 9 o'clock to 12 o'clock. That is a sacred 3 hours. No one can talk to me. I will not look at my email. I will not look at Twitter. I'm not going to read the newspaper. I just have 3 hours to do something. And it doesn't matter how much I get done, because some days will be bad. But I'm not going to fool around in those 3 hours doing anything else. And so that's when I would walk the dog or dictate, or if I'm editing, I'll edit. And it's only 3 hours. I'm not going to try to do 8 hours a day. That's too hard. At the rest of the day, I'm teaching, I'm meeting with grad students, I'm doing podcasts, whatever.
But you are not a millennial. You're not a millennial.
No, I'm a baby boomer.
And you're a baby boomer. And I think that your millennial grad students can't handle 3 hours of, no Twitter, no Facebook each day. Would you consider, the difference between you and your grad students, which are not fully committed or their attention span is much worse than yours?
I'm not sure I would say that. There's a lot of different kinds of graduate students. Some of them have great capacity to concentrate. So, and I don't really know what their work process is in most cases. I don't know whether they stay up late at night or work in the morning. There's a wide variety, so I wouldn't be prepared to make any generalization about them. But it is true that there's a lot of distractions today, TikTok and Instagram, and but like I do everything I can to turn off notifications. As soon as I get any new app, I'm turning off the notifications. I don't want anyone notifying me about anything. I need a lot of time to be quiet, to hear myself think and be confused and be creative. That's the most precious thing. So I don't know what the young people do today. I mean, they do a lot of multitasking, it seems, and I don't like multitasking. I can't even do 2 things at once.
It's a
let
myth.
alone.
It's a myth. And by the way, there are two great books about what you just said. One is Deep Work by Cal Newport, and the other is Digital Minimalism by Cal Newport also, which says...
Oh, yeah, Cal Newport. Yeah, I like his stuff.
Yes, yes.
Yeah, I like him. Yeah.
So deep work and digital minimalism, you don't need all your social media. And if you just cut it off, and of course, cut off the notification, which is, I don't believe in hell, in the biblical hell, but I do believe that the one who invented this or the like button is going to hell. He's going to hell. It's like what Elon Musk said to Mark Zuckerberg: you made your endeavor, your company lost so many hours of good work to just, BS, to nothing. And this is like, I think, just do something valuable with your time. I think that this is the lesson that we should learn from you.
Let me ask one question about social media, because it is an interesting discussion. It's had such a big impact on our societies around the world in terms of productivity, I think, and also sanity, like how people just, whether they're depressed or anxious from things. But so Jaron Lanier, who could also be an interesting guest for you, says we should delete our social, get off social media, just delete all your, right? Didn't he recently wrote a book, 10 Reasons or something to get off of the internet? Even though he was one of the people who had a lot to do with creating virtual reality and some other internet things that are popular. He says 10 reasons to delete your accounts. I have not done that. I'm still on Twitter. I never was on Facebook. I don't like Facebook personally, but I sometimes think maybe I should get off of Twitter too. Do you do? I didn't notice you anywhere. Are you on any social media?
I don't have. First, I consider YouTube to be not a social media platform.
I agree. It's not for me.
So YouTube is not a social media, but tutorial is a big magic word, but it's a bad word for, sometimes you get addicted to do tutorials. But if you put YouTube aside, I'm not on any social media. And I think that, in every decision that you make, there are pros and cons. Mm-hmm. But the pros for deleting all your social media, especially for productive human beings, is so bigger than the cons. Okay? Woody Allen doesn't write the script on the computer. He has like a very old typing machine. And Stephen King, again, he writes every day 3 hours, and he publishes like a book a year. And he doesn't have a computer. He has it's like a digital typewriter or something like this, okay? There is a quote by Chazal that it says, I will say it in Hebrew and then in English, I will try to translate. Al tavi'enu lo lidei nisayon velo lidei bizayon. I try to translate that don't put me in a test position because I will fail. If you want to be on a diet, don't put Coke in your fridge. Okay. So
yes.
And I think that the concept of Shabbat, that you are not allowed any social media, you are not allowed to work, is a very, very, it's a deep and profound concept to the modern life. And I would say yes, the cons of Twitter. I don't know about you because again, you're a baby boomer, but millennials and X generation and Z generations, wow. This is
I think I have a problem. I actually think even if I'm a baby boomer, I think I have an addiction. My younger daughter used the function on my phone that counts my screen time. She said, you should set a limit on your screen time. You're on Twitter too much. Yes. And you know what I did? I turned off the app. Because it was constantly telling me I already used up my 1 hour. And I felt like I'm not done. I need more. So I think I have a problem.
Yes, yes. It's like that in Israel, there is like an no porn internet. So it's very common for observant Jews and religious Jews, you have no porn internet. But in many no porn internet, you said, listen, Even iPhone has a screen time limit because
that's what I mean. That's what I'm talking about.
Even Apple said, listen, this is your time to sleep. This is your time for yourself. And when a man, approaches his death, never does he say, I wish I had more, I spend more time on Twitter. It's not the case.
I like your point about Shabbat. I mean, that really is a very deep lesson from the ancients, from the sages.
Yes.
That we need that time every week. And because of your very good comment about temptation, that if you tempt yourself, you will probably fail. So just make it a rigid principle. I'm not going to, that's sort of what I was doing with my 3 hours, except it was not Shabbat. It was my 3 hours of work, where I'm going to not look at social media. But it's a similar concept. No temptation. Be absolute about it.
By the way, yes, you should. At the end of our conversation, just delete the Twitter. Let me just tell you one more thing. That the essence of there is another profound idea in Shabbat, that it's not just about resting. It's not resting. In Shabbat, what you are not allowed to do is to create something new. You need to take the world. Yes. So all the things that you are not allowed to do according to the halacha is not to create anything new. You can think about new, but you cannot write, because when you write, as you probably know, when you write like a lemma or a theorem, you create something new. But there is one day that you need to get or accept the world as it is, and in the other 6 days you could operate in this world. But one day you need to think, okay, I'm just like a part of this great giant world, and I need to learn also accept it for one day, not because we are Western after all. Okay, one day, and I need to take or to accept the world as it is.
Well, since we're talking about midrash and interesting interpretations of these old teachings, can I mention my favorite one?
Yes.
So we're off the topic, but I think these are all sort of related. Since we're talking about God's, resting on the seventh day and not creating anything new on that day. In Genesis, Bereshit, there's this interesting question of why is the book written at the beginning with the second letter? Why doesn't it begin with Aleph? Why does it begin with Bet?
Oh, there are many. Okay.
Okay, so I'll tell you my favorite interpretation of this.
What's your answer?
I like the interpretation that the letter itself, which sort of looks like this, suggests in its very shape, in its geometry, that there's a kind of wall. There's moving forward into the opening.
It's like a bracket.
And then there's a part where you shouldn't go back. So don't ask about what is before the beginning. There's a certain, you can keep asking questions. Why? But at some point, there's a beginning. And I don't know. I think it's an interesting thought. I think it's a beautiful thought. I don't know if it's correct. I just love the genius of the rabbis that came up with this understanding.
Let me give you a chizuk. I don't know how you say it.
Another argument? What is a chizuk?
Strengthen your point. Let me stress
my point. Okay.
Strengthen your. Okay.
Strengthen the point?
Let me make your point stronger.
Okay, go ahead, please.
So now, one thing is so another example or another solution why it starts with the second letter, not with the first letter, is that even after you learn everything, you didn't even start.
Beautiful.
There is one thing, but I want to make your point stronger. There was a physicist named Lev Landau.
Yes.
He was a great physicist in Russia. He was a Jewish Russian, and he had like this very many book, Landau Lifshitz in physics, very popular books. And he wanted to start a school for genius adolescents in Russia. And he tested the kids themselves before he admitted them to the school. And one of the questions that he asked and this is one professor in Israel told me that he was part of this group. He asked why the gravity or the electric field is proportional to 1 divided by r squared. And this is one question. Now, you can say that, okay, because the electric field is like a sphere, so it should be r squared, because this is like the area of the outer thing of the sphere, but of the circumference. It's not the circumference. It's like
yeah,
I don't know how you. Okay, I'm sorry. I don't know.
Yeah, we call it the surface area.
Yes, but this is not the answer that he was aimed for. He aimed for one answer and one answer only. Any other answer, he said, no, this is not a good answer. And the answer that he aimed for was because there is no answer. There is no reason why. This is why. This is the only, he said, if a student gave any other answer beside, I don't know, there is no decent answer, he said, okay, you're not. And when I asked my wife, I came home that day and I asked my wife, you know, why the electric field is proportional to 1 divided by r squared? She told me instantly, because this is what God wanted. And she's a physicist. And then I told her, yo, this is the exact answer that Landau seeked for. There is no other decent answer beside. And yeah, you cannot be, and because if you ask why, you eventually come because, and there is no answer, or this is what God wanted. I don't know why. I really don't know why.
Mm-hmm. So yeah, it's an interesting question. I mean, is the lesson then don't ask too many questions, or don't ask about fundamental, or because I mean, I think that's a very anti-Jewish principle, right? We are all about asking questions.
Yes,
it's in the very name. In the name
Israel, we are
wrestling with God.
My wife is here, and she's like the living spirit behind everything, and she listens and she asks me, can I say something? So with your permission, Reli,
right?
Time and join me. She is like the physicist, okay?
Hi.
Ah, there she is.
There she is.
Hello. Have you been listening?
Yes, I have.
Hi,
It's
nice to meet you. My wife
Hi.
is here too. I'm sorry, what?
Okay, answer, Stephen.
Hi, so listen.
Hello.
The thing is this. I've been thinking about this for 20 years, and this is my conclusion. You are definitely meant to ask questions all the time and to understand how the world works. Mathematics and physics are the languages God speaks. And he meant for us to understand these things. Think about it. The same logical, the same mathematical principles that allowed us to count sheep and to calculate areas of land are the same mathematical principles that govern the physical behavior and chemical behavior of the world. This is unfathomable. This is amazing. This is God's wish for us to understand it all. It makes sense that he wants us to know these things, these secrets. He wants us to understand him and his logic. And these are his languages. So of course you have to ask questions, but realize as you're asking these questions, he made it so that you can understand. He created this whole thing. He's like behind the scenes, happy for you that you made another step forward. But in the end, he just created it that way.
I see. Well, it's a nice vision. It's a very reassuring vision. God as a great teacher that gives us lessons that are just hard enough, that they're challenging, but not so hard that we can't eventually get them.
And again, in halacha, we must apply logic. We must apply reason, because sometimes in halacha we say, okay, if I can extract this law from reason, from logic, I don't need to go and search from the specific pasuk, from specific verse. I can do it with reason. You need to learn with reason. This is like the human mind is a tool that helps you understand math, logic, chemistry, everything, but also understand with your restrictions or איך אומרים, מוגבלות? With your limitations, God. And this is great. Wow, this was a fantastic talk. Steven, thank you so much for your time. It was great. It was great.
And on a personal note, I just have to say thank you, because there was a question about whether you're going to make it or not. And thank you for your answer. You're wonderful.
Oh, very good. Thank you. Well, I'm happy to have done it. And nice to meet you.
Thank you so much. I will send you the YouTube or the conversation once we upload it. Okay?
Good. Okay. Very good. Thanks.
It's been
glad we could have the conversation.
Okay. Thank you so much.